Now come to the reactions involving cleavage of carbon-oxygen bond in alcohol. The reactions involving cleavage of carbon-oxygen bond takes place only in alcohols. Phenols show this type of reaction only with the zinc. First type of reaction with hydrogen halide. Alcohol react with hydrogen halide to form alkyl halides. We have discussed this reaction in the previous chapter of haloalkane and haloarenes. Now let's quickly revise the reaction. Here this is alcohol. When it reacts with halide, it gives haloalkane and water is removed as a byproduct. The difference in reactivity of three classes of alcohol with HCl distinguishes them from one another. It is also known as Lucas test. Alcohols are soluble in Lucas reagent, which is a concentrated HCl and ZnCl2, while their halides are immiscible and produce turbidity in the solution. In case of tertiary alcohol, turbidity produces immediately, as they form halides easily. Primary alcohols do not produce turbidity at room temperature. So this Lucas test is used to distinguish between primary, secondary and tertiary alcohol. Now let's try to understand the reaction. Lucas reagent is the mixture of concentrated HCl with ZnCl2. And alcohols are miscible in this Lucas reagent. So here if I take the example of tertiary alcohol, when it mixed with the Lucas reagent, it gives turbidity immediately because it results in the formation of tertiary alkyl halide. And this formed alkyl halide is not miscible with the Lucas reagent. That's why it appears as a turbidity in the solution. While in case of primary alcohol, turbidity do not appear at all because they do not react with the Lucas reagent. So primary alcohol react very slowly with the Lucas reagent. So that's why it doesn't give turbidity at room temperature. So you won't get turbidity at room temperature, but slowly it results in the formation of primary alkyl halide. So let's take an example, ROH. This is alcohol when it reacts with HCl. Oxygen has lone pair of electron, so one of the lone pair abstract H plus from the HCl and it results in the formation of protonated alcohol. In this protonated alcohol, oxygen carries positive charge as it abstracted hydrogen from HCl. Now this protonated alcohol undergoes substitution reaction, nucleophilic substitution reaction with Cl negative ion and expel water molecule. So here you will get RCl, which is alkyl halide, and water is removed in the form of byproduct. Now come to the second reaction, reaction with phosphorus trihalide. Alcohols are converted to alkyl bromide by the reaction of phosphorus tribromide. This reaction also we have discussed in the previous chapter of haloalkane and haloarenes. Now come to the dehydration. Alcohols undergo dehydration, means the removal of water molecule, and they form alkenes on treating with protic acid, for example concentrated sulfuric acid or phosphoric acid, or catalysts such as anhydrous, zinc chloride or alumina. So here alcohol gives alkene. It undergo alpha beta elimination. Carbon bonded to OH is the alpha carbon and the carbon next to it is the beta carbon. So OH is removed from the alpha carbon and H is removed from the beta carbon. So that's how it results in the formation of alkenes. And water is removed. That's why the reaction is called as dehydration. Ethanol undergo dehydration by heating it with concentrated sulfuric acid at 443 Kelvin. So when ethanol heated with sulfuric acid, it gives ethene and water is removed as a byproduct. This reaction carried out at 443 Kelvin temperature. While secondary and tertiary alcohols are dehydrated under milder conditions. The OH group is bonded to the center carbon and center carbon is bonded to two another alkyl group. So that's why this alcohol is secondary alcohol. This secondary alcohol undergoes dehydration at 440 Kelvin temperature with 85% phosphoric acid. Here this is the alpha carbon to which OH is bonded, and this alpha carbon is bonded to 3 alkyl groups. So that's why this is tertiary alcohol, and it undergoes dehydration at 358 Kelvin temperature with just 20% phosphoric acid. So thus the relative ease of dehydration of alcohol follows the following order. Tertiary alcohol react faster than secondary than primary. The mechanism of dehydration of ethanol involves the following step. So let's try to understand the mechanism of dehydration. So this is the first step of dehydration. First step is the formation of protonated alcohol. Now let's try to understand the reaction. So let's take the example of ethanol. So this is CH3 CH2OH. When it reacts with the acidic medium. In acidic medium, H plus will be present in the reaction medium. And we know oxygen has two sets of lone pair. So oxygen will abstract H plus from the reaction medium, and it results in the formation of protonated alcohol. So here you will get CH3 CH2OH, and now this oxygen has made bond with the H plus ion by the donation of lone pair. So this oxygen will develop positive charge. So this is the first step of the reaction. First step is the formation of protonated alcohol. Now come to the second step of the reaction. Second step is the formation of carbocation. This is the slowest step, and hence it is the rate determining step of the reaction. Now this H2O positive ion will leave the molecule in the form of water molecule, and it results in the formation of carbocation. So here you will get CH3 CH2, and water is removed as a byproduct, and this carbon will develop positive charge as it has donated bonding pair to oxygen. This is the second step of the reaction, and this is the rate determining step. Rate determining step. Now come to the third step of the reaction. Third step is the formation of ethene by the elimination of a proton. Now let's expand the structure of formed carbocation. So here this carbon has made bond with the 3 hydrogen, and here this is the positive charge over carbocation, and here it is hydrogen. In this step, the bond between carbon and hydrogen will shift between two carbons, and hydrogen is removed in the form of H plus ion. So here you will get H plus ion and ethene, HCH, double bond CH, H. So this is ethene, will be formed as a product, and this is the third step of the reaction. Here when you see H plus was consumed in the first step of the reaction, and it is regenerated in the third step of the reaction. So that's why H plus is a catalyst. So this is act as a catalyst. Now let's read from the book. The acid used in first step is released in step 3. To derive the equilibrium to rate, ethene is removed as it is formed. As the third step is the reversible step of the reaction. This third step is the reversible step of the reaction. So as soon as ethene is formed, should be removed from the reaction medium to facilitate the reaction in the forward direction. Now come to the fourth type of reaction, which is oxidation. Oxidation of alcohol involves the formation of carbon-oxygen double bond with the cleavage of oxygen-hydrogen and carbon-hydrogen bonds. Such a cleavage and formation of bonds occur in oxidation reaction. These are also known as dehydrogenation reactions, as these involves the loss of dihydrogen from an alcohol molecule. Depending on the oxidizing agent used, primary alcohol is oxidized to aldehyde, which in turn oxidizes to carboxylic acid. So here, when you observe the reaction given here, this is primary alcohol. After oxidation, it gives an aldehyde. and on further oxidation it gives carboxylic acid. Strong oxidizing agents such as acidified potassium permanganate are used to getting carboxylic acid from alcohol directly. So if you want to get carboxylic acid directly from an alcohol, you should use a strong oxidizing agent like acidified potassium permanganate, CrO3 in anhydrous medium is used as the oxidizing agent for the isolation of aldehyde. To get the carboxylic acid directly from alcohol, you should use acidified potassium permanganate. But if you want to stop the oxidation at aldehyde stage, you should use anhydrous CrO3. A better reagent for oxidation of primary alcohol to aldehyde in good yield is Pyridinium chlorochromate. This is also known as PCC. Pyridinium chlorochromate. PCC is a complex of chromium trioxide and pyridine and HCl. Now let's observe the given reaction. Here in this reaction, double bond is there and alcohol functional group is also there. When it is treated with PCC, it gives an aldehyde, but the double bond is remain unaffected. So when PCC is used, it attack only on the alcohol functional group and oxidize that alcohol functional group to aldehyde functional group, but it doesn't affect the double bond present in the molecule. Secondary alcohols are oxidized to ketones by chromic anhydride. When you use CrO3 with the secondary alcohol, it gives ketones. Now come to the tertiary alcohols. They do not undergo oxidation reactions. Under strong reaction conditions such as strong oxidizing agent like KMnO4 and elevated temperature, cleavage of various carbon-carbon bond takes place and a mixture of carboxylic acid containing less number of carbon atoms are formed. When the vapors of primary or secondary alcohols are passed over heated copper at 573 Kelvin temperature, dehydrogenation takes place and an aldehyde or a ketone is formed, while tertiary alcohol undergo dehydration. Now let's examine the reactions given here. This is primary alcohol. On passing the vapors of primary alcohol over heated copper, it gives an aldehyde. This is the secondary alcohol, and when the vapors of secondary alcohol passed over heated copper, it gives ketone. And this is the tertiary alcohol. When the vapors of tertiary alcohol pass over heated copper, it undergo dehydration. Dehydration means the removal of water molecule. So here water is removed from the alcohol molecule and it undergo alpha-beta elimination. Carbon to which OH is bonded is the alpha carbon and the carbon next to it is the beta carbon. So there are 3 beta carbons. They all have same number of hydrogens. So you can remove hydrogen from either of the carbon. So when you remove hydrogen from one of the carbon, here you will get double bond between 2 carbons. And rest 2 methyl group will remain as it is. So here you will get isopropene. So that's how you will get alkene by the dehydration of tertiary alcohol. In the next video we will discuss the reactions of phenol.